Namaste. Welcome to the Department of Mechanical, Materials and Aerospace Engineering. We are excited to share some of the highlights of our department programs. The department was started in 2016 as one of the core branch mechanical engineering. Later on, it was renamed in 2019 as a Mechanical, Materials and Aerospace Engineering. So to cater more research areas and then the different programs. Presently, the department offers different programs at UG level, BTech in Mechanical Engineering, at PG level, MTech and MS and then PhD programs.
Our curriculum is designed to equip students with theoretical and practical knowledge. To ensure industry relevance, our courses are tailored to meet the current industrial requirements. Core courses include thermodynamics, fluid mechanics, mechanics of materials, design of machine elements, and manufacturing processes. Additionally, students can also get hands-on experience through core courses in engineering materials, theory of machines, heat transfer, and applied thermodynamics. Apart from the core courses, we do offer some electives such as rocket propulsion, additive and forming manufacturing processes, advanced solid mechanics, advanced fluid mechanics, heat transfer, FEM, CFD, and smart materials and structures, and many more.
Our laboratory courses such as heat transfer lab, solid mechanics lab, and manufacturing processes lab provide essential practical exposure to the students, enabling precise manufacturing and ensuring effective communication among engineers, architects, and manufacturers. Then we have hands-on engineering laboratory. This lab is crucial for applying theoretical concepts, developing problem-solving skills, and gaining hands-on experience with engineering tools and techniques.
So most of the core courses are followed with the corresponding laboratory courses to reinforce the theory via sophisticated experimentation. We also cater to current industry needs with specialized laboratories such as computer programming laboratory, machine trial and 3D laboratory. In our fluid mechanics laboratory, students explore fluid behavior and its applications. Manufacturing processes and methodology laboratory focuses on precision, quality control in manufacturing. The strength of materials laboratory allows for hands-on testing of material properties under various conditions. In the mechanical measurements laboratory, students gain skills in accurate data collection and analysis of various properties. The dynamics and dynamics of machinery laboratory, which is related to theory of machines, explores the motion and forces in mechanical systems. The heat transfer laboratory offers insights into thermal systems and energy transfer, and lastly the thermodynamics laboratory complements this with the practical thermodynamics applications. So each lab is equipped in such a way to support our diverse and dynamic learning environment.
We offer certain minor degree programs to students to help them acquire a reasonable exposure to other disciplines. For example, an undergraduate student in mechanical engineering department can take a minor degree in computer science or data science and artificial intelligence, or minor degree in mathematics. For this, they need to acquire certain number of predefined additional credits apart from their regular credit requirements. And we also encourage, even without minor degree, some additional exposure to additional courses which are interdisciplinary electives. For example, data science and data analysis or machine learning.
For both UG and PG students, ample opportunities of industry interactions are available in our department. MTech students in particular have a choice to engage in academic or industrial research activities during their second year, which significantly contribute to their academic and career growth.
With our research facilities, we have various machining capabilities for advanced manufacturing, such as sheet metal CNC laser cutting machine, which can effortlessly transform sheet metal into precise, intricate designs with stunning accuracy. We have a robotic arm welding system, which is used to deliver flawless welds with unmatched speed and consistency. Our facilities include wire cut EDM, which uses fine wire to cut through metal with extraordinary accuracy, creating intricate shapes and details with a flawless finish. We also have VMC machine and CMM.
Our department also has facilities for 3D modeling, computational simulations, and material testing. For example, we have 3D handheld scanner that can scan surface texture and geometry precisely. We also have 3D printers, for example, SLS 3D printer or FDM or PolyJet, just to name a few, that can precisely 3D print for prototyping. We apply computer vision and 3D modeling for advanced design and control. We use our inbuilt in-house computational tools and codes, this along with commercial codes such as Abacus, ANSYS or SolidWorks.
Apart from that, we have a rheometer which helps us to characterize various fluid flow behaviors with highest quality of standards. Our facility is also equipped with a high-speed camera capturing fast movements with incredible details for precise analysis and insights. Our lab also has an LDV, also known as laser Doppler vibrometer, that measures fluid flow speed with incredible accuracy, giving us deep insights into fluid dynamics. Our IR camera detects heat patterns, allowing us to visualize and analyze temperature variations with precision.
In addition to our department facility, we are having the central facility is called as a sophisticated central instrumentation facility, rated as SAF. This includes high-end instruments such as SEM, AFM, HPC, XRD and UTM.
Coming to research work, our department is involved in research activities in different verticals of manufacturing, design and fluid and thermal engineering. The research areas include computational mechanics, multi-phase flow, biomechanics, robotics and automation, thin film dynamics, physical metallurgy, manufacturing processes like casting, welding, to name a few.
Our faculty are actively engaged in several research areas, including computational fluid dynamics, using methods like Lattice-Boltzmann, finite volume method, and discrete element approaches. We also investigate areas such as crystal plasticity modeling, lightweight and high temperature materials, and computational material design. Our work extends to editing manufacturing techniques like 3D, 4D printing, directed energy deposition, smart materials, and others.
Here, we are pioneers in different areas of research, one of which is blast analysis of composite material. We have state-of-the-art research facilities in different areas, which include vibration analysis, experimental mechanics, tribology, surface treatments, and coatings. We have our faculty members engaged in areas of research which are very specific and cater to the needs of the existing industry, and the areas such as industrial technologies for Industry 4.0, advanced manufacturing processes, and smart materials are some of the key areas of research. We are particularly excited about our contributions in the field of biofluid mechanics, solar thermal energy, and hydrogen combustion.